What if I told you the real power behind peptides isn't the peptide itself? It's what it connects to. Inside your body are millions of tiny locks, and peptides are the keys. But here's the twist. Not all locks respond the same way. Some stop working, some become overactive, and that changes everything. Today, we're breaking down peptide receptors, what they are, how they work, and how to keep them responsive. What are peptide receptors? Let's simplify this. A peptide receptor is a specialized protein, usually sitting on the surface of a cell. Its job is simple. Detect a specific peptide, bind to it, trigger a response inside the cell. Think of it like a signal receiver, a lock waiting for the right key, a notification system for your cells when the correct peptide binds. The receptor activates, a signal is sent inside the cell changes behavior. That could mean releasing hormones, starting repair processes, adjusting metabolism, sending signals to other cells. No receptor equals no signal. No signal equals no effect. That's how important receptors are. Types of peptide receptors. Not all receptors work the same way. There are three main types you need to understand. G-protein coupled receptors, GPCRs. These are the most common. They sit on the cell surface and activate internal signaling pathways when triggered. Examples include receptors involved in growth signaling, appetite regulation, hormonal communication. Think of GPCRs as signal translators. They take an outside message and convert it into action inside the cell. Enzyme-linked receptors. These receptors don't just receive signals. They activate enzymes directly once a peptide binds. The receptor triggers a chemical reaction. This leads to cellular changes like growth or repair. These are often involved in tissue regeneration, cellular growth, processes, metabolic control. Ion channel-linked receptors. These are fast. When activated, they open channels in the cell membrane. Ions flow in or out. Electrical signals change instantly. These are key in nerve signaling, muscle contraction, rapid cellular responses. Quick summary. Type, speed, function. GPCR, medium signal amplification. Enzyme-linked, slower growth and repair. Ion channel, fast electrical signaling. Why peptide receptors matter. Here's where things get interesting. Peptides don't act randomly. They only work if receptors respond. And receptor behavior changes everything. Sensitivity, if receptors are highly sensitive. Small signals create big effects if sensitivity drops. Even strong signals do very little. Density. More receptors equals stronger response. Fewer receptors equals weaker response. Your body constantly adjusts receptor numbers based on exposure. Desensitization, if receptors are constantly activated. They tune out. Response decreases over time. This is called downregulation. Specificity, each receptor is designed for a specific peptide. Wrong match equals no response. Bottom line, the receptor, not the peptide, often determines the outcome. How to optimize receptor sensitivity. Now let's talk optimization. This is where most people get it wrong. They focus on increasing input, but ignore the receiver. Avoid constant stimulation. If receptors are triggered non-stop, they become less responsive. Spacing out exposure helps maintain sensitivity. Support cellular health. Receptors sit on cell membranes. That means cell health equals receptor performance. Key factors: proper nutrition, healthy fats, membrane integrity, sleep quality, reduced inflammation. Signal cycling. Your body responds best to pulses, not constant signals. Natural systems work in rhythms. Pulsatile signaling keeps receptors responsive. Constant signaling dulls response. Reduce noise. Chronic stress, poor sleep, and metabolic dysfunction interfere with receptor signaling. Lower responsiveness. Think of it like static on a radio. Receptor recovery time. Just like muscles, receptors need recovery time. Overuse reduces performance. How delivery methods affect receptor interaction. This part is critical and often misunderstood. Different delivery methods change how peptides reach receptors. Oral, swallowed, problem. Broken down in digestion, very little reaches receptors. Intact, result. Weak or inconsistent interaction sublingual. Under the tongue, better absorption than oral. Enters bloodstream faster, bypasses digestion partially but still. Limited consistency transdermal. Skin, patches/creams. Peptides struggle to pass through skin barriers. Absorption varies, often inefficient for larger molecules subcutaneous. Under the skin, most commonly used for systemic effects. Slow, steady absorption, sustained interaction with receptors, intramuscular, faster absorption than subcutaneous. Stronger, quicker peak, shorter duration. Key insight. Delivery method changes. Speed of receptor activation, duration of signaling, intensity of response. So here's the real takeaway. Peptides don't control the outcome, receptors do. If receptors are sensitive, right arrow, strong response. Overstimulated, right arrow, weak response. Damaged, right arrow, no response. Understanding receptors means understanding the system. Final line. If peptides are the message, then receptors are the decision makers. If you want to understand peptides at a deeper level, not just surface level hype, subscribe. Because the next video will break down why some peptides stop working over time and how to prevent it.